Welcome to the first Flat Earth Thursday actually on a Thursday. Today's video is the video that I was planning on doing on Tuesday, but because this video was almost 7 minutes long, I decided to push it back to Flat Earth Thursday instead. Today's video was found on TikTok on Another Perspective 7's page. I believe that the video was made by someone else. The problem with TikTok is that people will take YouTube videos and re-upload them on their page without giving any credit. When I think that that has happened, I will go and try and find the actual source and use that instead. I couldn't find one for this video. If you do know where this video is from, please leave it in the comments below. Now let's take a look.
If the Earth was actually a globe, spinning at a mind-numbing 1,000 miles per hour, how is it that we do not feel its motion? There is not a single person on Earth that can testify to feeling the Earth's alleged spin.
Let's stop here real quick. This is something that flat earthers do to misrepresent the globe. Saying that the globe spins at 1,000 miles an hour may seem mind-numbing. First of all, this is an extreme that only happens on the equator. The closer you get to either pole, the slower that you will be. When standing on either poles, it is less than a mile per day. To show the correct way to measure the Earth's rotation, let's picture a merry-go-round. If you were to measure this in the same way at the edge, you will be traveling about 15 miles an hour, let's say. But in the center, you will only be rotating with no actual travel. That's why measuring the Earth's rotation in miles per hour makes no sense. When measuring angular rotation, you measure in revolutions per minute. The second hand of a clock has an RPM of 1. It rotates around the clock once per minute. The minute hand has an RPM of 0.016. A more accurate measurement for this would be revolutions per hour, because it's so slow, and the hour hand spins at 2 revolutions per day. The Earth spins half as fast as this, at 1 revolution per day. This can also be said as 15 degrees per hour. If you were to sit on the merry-go-round from earlier that was spinning at a constant 15 degrees per hour, or 1 revolution per day, you would probably not be able to feel any motion.
We feel the motion when travelling in a car, train, boat, plane, and can experience motion sickness. The scientists magicians will tell you that we do not feel the Earth spin because it is spinning at a constant speed. They often use the analogy of a train ride. We only feel that we are moving when the train changes speed. This analogy, however, falls apart when you consider that in the heliocentric model, the Earth is not an enclosed system, but it is an open environment with its own drastically changing weather. If you were sitting on top of the train moving at a constant speed, and not inside it, you would certainly feel the motion.
This TikToker makes the analogy of sitting on top of a train and saying, this is what it would be like if the Earth was moving through space. This is fundamentally flawed. The reason you feel the motion of a train while sitting on top, as opposed to inside, is due to the air outside of the train staying still and you moving into it. This is called air resistance. The Earth moving through space does not encounter air resistance because there is no air in space to push against it.
Furthermore, they also contradict themselves. In a 2016 article titled NASA Study Solves 2 Mysteries About Wobbling Earth, they state that the Earth does not always spin on an axis. Instead, it wobbles irregularly over time, and that the direction has changed drastically due to changes in water mass on Earth. It's weird that no one has felt this. Which one is it, NASA? The stealthy, unnoticeable spin, or irregular movement patterns and wobbles?
It's actually both. The study that he is referring to talks about how the axis moves as water redistributes from the Ice Age. The axis slowly rotates around the pole at about 7 inches per year. That translates to 0.5 millimeter per day. Anyone that tells you that they can feel 0.5 millimeter of movement is lying to you.
The whole notion of a spinning globe becomes absurd when you consider this. If the Earth was actually rotating, then helicopters and balloons would only need to hover over the surface and wait for their destination to come to them.
Flat earthers like to pretend like the Earth and atmosphere are 2 separate objects. Again, let's picture the train. When standing in a train and bouncing a ball, the ball doesn't go shooting back to the back of the train. This is because of inertia. The ball keeps its forward direction when you let it go. The atmosphere is the same as the air in the train. The air in the train is also moving with the train, so it does not push the ball backwards. Let's take a look at someone who put this to the test. In this video, the person is bouncing up and down on a trampoline while the truck is moving forward. This is the same concept as the helicopter taking off from Earth.
Similarly, if it were a curved spaceball, then aeroplane pilots would constantly need to readjust their altitude downwards so they did not continue straight and start heading out to space. They would have to descend 2,777 feet, or over half a mile every single minute. This of course is not the case, and pilots are never instructed or taught this mechanism of flight.
That is because they don't have to. Gravity is pulling on the plane. A plane would have to be traveling at 25,000 miles an hour in order to worry about correcting. This 25,000 miles an hour is the speed needed to overcome Earth's gravity to leave the atmosphere. This is the speed that rockets fly. Even the world record flight for an airplane is 2,100 miles an hour, done by a Lockheed SR-71. The average airline travels at about 575 miles an hour, nowhere near the speed needed for any amount of correction to go around the curve. This next section is a bunch of people harassing airline pilots to get them to say that the Earth is flat. And since airline pilots aren't flying fast enough or high enough to see or feel the curve, then their opinions are just as baseless as anyone else based on their own observations. So I'm going to skip that part.
If the Earth is actually rotating, flight paths would become very messy. Flying west from New York to California is 2,441 miles, which takes just under 5 hours on a commercial flight. If the Earth is spinning eastwards at 1,000 miles per hour, then not only would this flight take a lot less time, but it would also make it near impossible to fly back the other way due to the constant rotation of the Earth. It would be like trying to run up a very long and very fast downward escalator.
Again, just like the helicopter, the plane is in the same inertial reference frame as the Earth. So, just like the man on the trampoline on the truck, the rotation of the Earth does not matter.
And what about the weather? If the Earth and atmosphere is spinning at 1,000 miles per hour, then don't you think it would be impossible to see such stationary clouds and weather formations like we do? Not to mention that clouds often crisscross in their pathways. This would be impossible if the Earth's spin was a reality.
The clouds appear to be stationary for the same reason as the plane. They are moving with us. There is no difference in speed between the Earth and the atmosphere.
And honestly, if the Earth was a fast rotating globe, then wouldn't the oceans and other bodies of water be pushed away from the Earth in the same way as when a wet tennis ball is spun rapidly, the water sprays outwards?
They are. And not just the oceans, the land too. The Earth is not perfectly spherical. It's called an oblate spheroid. It bulges at the equator. There is actually a 28-mile difference between the circumference of the equator and the poles. But because we are only rotating at 15 degrees an hour, gravity is plenty strong enough to keep the water on the ball. The tennis ball is probably spinning hundreds of times faster than the Earth.
The scientist magicians have an answer for this. They call it gravity.
And by the way, this is called gravity.
I find it funny that he ended with a mic drop from Neil deGrasse Tyson, especially since his last point had less to do about gravity and more about his innate inability to understand the heliocentric model. And that's it for our first Flat Earth Thursday, actually on a Thursday. Come back next week for another TikTok Tuesday.